Everyone. I'm Elizabeth Rojas. I'm the 2030 District Director, and I am thrilled to be able to offer this these 50% solution series for your webinar. And we're very grateful to GoSustainable today for presenting. We have Greg Raffio and we have Chris Wagner that are going to talk about getting to carbon neutrality even with our existing buildings, and what that roadmap might look like. Just a couple of things I'd like to say. You are welcome to join via your video, your camera. If you would please mute yourselves during the presentation. We do have a chat box that's open, so if you want to ask any questions along the way, feel free to type your questions into the chat box. At the end of the presentation, we'll open it up and you can unmute yourself and ask a question, and then mute yourself afterward. So again, we are really happy to have all of you here. These are definitely unprecedented times, and we recognize that everybody's taken an effort to come and join us today. With that said, this programming is brought to you for free and open to the public right now, and we want to serve the community in this way, but we also would welcome your donations. And so if you wish to donate to the 2030 District, you can go to Green Umbrella's website, and you can even specify that any donation that you wish to give us will go specifically to the 2030 District, and that will help us continue to bring you programming. So with that said, I am going to pass it over to Chris and to Greg, and I look forward to connecting with all of you. Feel free to send us your comments and your feedback. We are going live today. This will be live on Facebook. So. All right, I'll send it over to you guys.
All right, thanks, Elizabeth. This is Greg Raffio here. I'm going to do the old screen share, mumbo jumbo, and let me know when you can all see everything. Elizabeth, I can't see the presenters right now, so let me just give me a verbal if you can see the screen.
Looks good, Greg.
Okay. So, hey everybody, thanks for coming during this presentation, Pandemic Edition. My name is Greg Raffio with GoSustainable Energy. I'm joined here by Chris Wagner as well from our staff. I'm up here in Columbus in my basement, and Chris is in Cincinnati in part of his place. So today we're going to talk about the untapped potential of existing buildings in the quest for carbon neutrality. And I do encourage you all, again, as Elizabeth said, chat in any questions. I'll have Elizabeth or Tom or Chris kind of moderate and stop me during the presentation if there's a pertinent question right on that slide, or we can hold to the end. This presentation is based on a paper we wrote for the 2018 ACEEE Summer Study for Energy Efficiency in Buildings. And also, if at any point in time I cut out audio-wise, feel free to ask me to rewind. So we'll go ahead and get started. The untapped potential of existing buildings. So there'll be some things we want to talk about today. I'll go through a little bit of climate context, talk about zero energy buildings. We'll talk about the Ohio History Center, which is the main part of the case study, the focus building here. We'll talk about deep energy retrofits, maybe what a path to zero energy would look like, power purchase agreements, and then some time for throwing rocks. And warning, there will be baby pictures. I figured you could use some cuteness in your days if possible. Some of these kids might be cute. They're both mine. And where you see a baby picture, I was trying to make my slides less boring. So let's just be honest. So here we go. Our team is GoSustainable Energy. The reason I want to mention us is this is the last time we were non-social distancing together. Since then, we've added 2 more people. We are energy consultants. We provide third-party accurate unbiased information on energy. So it comes
Hey, Greg, you're breaking up.
Still breaking up there? How is this for now? Everything okay right now?
Clear now, but we only got to the part where you talked about adding 2 new people to your team. After that, it kind of broke up.
Sorry about that. Yeah, so basically this is our team. our collective experience in consulting with people in energy efficiency really helps bring some stories together. And so we were thinking through, what is this whole, climate context? Where are we going with things? How are clients and how is the world responding? And so we thought we had an interesting case study. That's all I really wanted to say. So a little bit of climate context. For those of you paying attention to climate change, our goal is to get below 350 parts per million CO2 in the atmosphere. Every time I check the recent CO2 numbers from Mauna Loa in Hawaii, the graph on the right goes up. So the graph on the left is a couple year snapshot. Any 5-6 year snapshot looks basically identical except for the vertical axis changes. The purple line over here on the left is where we have to be if we want to avoid catastrophic climate change, if we want to listen to the climate scientists about that. And so as you can see, we're still moving slightly away from that target. So we got some things we got to work on. So why do we care in Ohio? There's a traditional, hey, the coasts are going to have sea level change. Polar bears are just at the zoo for us here in Ohio, maybe, a little bit tongue in cheek there. We don't have ocean beaches, and hurricanes tend to send us nice warm rain. So the catastrophic effects of climate change, maybe from the direct water perspective, don't feel as real unless we're seeing the people affected in areas affected. This is one of the best graphics I've seen. I stole this from a citation at the bottom from the Bird Center at OSU up here in Columbus. This is a graphical representation of Ohio's weather over the course of the coming century. We're not designing buildings for Arkansas summers. And I don't think a lot of corn and soybeans in the agriculture industry that we have very strong here in Ohio exist in the same weather regions that we're marching towards. So just another graphical close to home reason on why they care, besides really all the other obvious reasons they care. But it's always good to think about what's the local impact? What are we directly going to see? So I'm breaking PowerPoint 101, but I put 2 direct quotes up here for everyone's absorption. This is from a recent UN emissions gap reporting from the end of last year. And one of the most important statements they have here is how we are going well beyond the scientifically agreed upon 1.5 degrees Celsius, which is our target for maximum warming. When we get past this point, the impacts of catastrophic climate change are going to be very real. And right now, all the data, even if countries meet their non-binding agreements, we are well on the course to beyond double the amount we're going to. So there's a reason to really focus on the fact that we're not getting there. We're not making the progress we need to see, and we don't have as much time as we think we have. Let me jump into zero energy buildings. That's the temporary doom and gloom, right? So let's get into how we're going to do this. So zero energy buildings is a concept that has been thought about for quite a long time and started to be actually deployed. The concept of zero energy buildings is that pretty much over the course of a year, a zero energy building will both produce and consume the same amount of energy. Now, there are 5 widely different definitions of this. You can go to site, source, cost, emissions, and surprise, California has their own definition, of course. However, I think we kind of have a damn the torpedoes approach when we think about definitions. Who cares? They're all increasing efficiency, reducing building energy consumption, and all promoting the deployment of on-site or local renewable energy, which is all the common goal across these definitions. So I get together once in a while with some other nerds like myself in the energy industry every so often, every other year, every year or so. And usually there's a group who are off in the corner arguing about definitions. And then there's a group that I'm sitting with who are saying, why don't we get to 1,000 of each of these before we really start hashing out the definitions? We still have a lot of progress to make before the actual definition matters. So this map you see here is not cases of COVID-19, although that would actually probably be a better version of the map that we see than we see on the news today. This is a map of the US this is from the New Buildings Institute. This is the existing and verified zero energy buildings that are out there. So basically, all the alphabet soup you see up in the left-hand corner: Department of Energy, National Renewable Energy Lab, International Living Futures Institute, New Buildings Institute, ACEEE, et cetera. All these organizations are starting to look at and promote the data collection revolving around zero energy buildings. And they're heavily focused in California, but you can see that they're all around the country. There's data on 81 independently verified actual zero energy buildings with performance data to back it up. And there's another almost 500 emerging buildings, which at least in design and or late construction planning are plausibly on track to possibly meet a zero energy target. Now, there are way more than 600 buildings out there in the United States. In fact, this is a tiny fraction, but it's good to see the case studies going out there. So for a few years, people were arguing about zero energy buildings and asking the questions of if and where. The if and where and how questions have been generally answered. There's the technology's been proven, the case studies are out there, and even the cost analysis and economic analysis have been pretty well proven out that you can do zero energy buildings at a low to no cost add-on, especially if you do it over cash flow over the lifetime of a loan or the construction loan for a building. The remaining barriers that we see in the zero energy buildings industry tend to be on the end of perception of, does anyone even know what a zero energy building is? And also the market, who's actually asking for one? You know, I talk to lots of folks who say, of course we can make zero energy buildings. My clients aren't asking for them. So I think that's really where the focus is on this. But I want to focus in on the fact that predominantly these buildings on this map are new construction. And let's play out this scenario a little bit. So if we go back to this whole catastrophic climate change thing, let's pretend that in the year 2030, that we meet the AIA's goal of building all zero energy buildings, 100% of new construction starting in the year 2030, 10 years from today, is all new construction net zero energy buildings. Now, reminder, we have to be to a carbon neutral, zero emissions total net economy by the year 2050 if we are going to bend this other curve we're all worrying about, the climate curve, to meet that 1.5 degrees Celsius target. At the current rate and the normal rate of the building sector, buildings turn over at about a 1% to 2% turnover rate per year. That puts us out into the year 2080 to 2130 by the time all of buildings are zero energy, zero carbon, zero whatever we decide, which is 30 to 80 years past the 2050 zero carbon economy goal. So if that's true, taking a new buildings, that's a typo on the slide there, a new buildings, new construction only approach misses this goal. So the two methods that we know of in the existing building space, the building space, is massive grid scale renewables. So the grid flipping over to being low carbon or renewable energy, and also a massive push into existing buildings. So the rest of this presentation is going to focus on existing buildings being part of the key of getting us to this 2050 zero emissions economy. So we got a cool building to think about. It's the Ohio History Center, speaking of existing buildings. For those of you familiar with Columbus, it's on Interstate 71, right next to the old Cruise Stadium, which is being rebuilt somewhere else in the state. There's a quick picture of the building and some of the former employees that were there. Both of them actually no longer work at the organization, but they were who I had for this slide. The Ohio History Connection is a statewide nonprofit. It has a lot of sites around the state. It's got some cool stuff it does, and you can see a small collection of Star Wars toys in the right side there. I was on a little personal tour, and they happened to pull out some of their Star Wars collection, so it was kind of fun to see. The Ohio History Connection, the organization, operates this building, the Ohio History Center. So this building is having its 50th birthday this year. It was designed back in the brutalism era, which was, the era of lots of massive exposed beams and concrete, and architects will have some way more interesting comments about brutalism than I will, because I'm an engineer and I don't think in aesthetics. However, this building was one of the first adopters of a green roof in the state. In fact, maybe 2/3 of the building sit underneath a massive green roof. This building has a gigantic triangular tripod at the base with this floating brick of a rectangular square sitting above it. So really cool building to check out. So this is a terrible slide, but it's kind of necessary. And it reminds me of what this building has been doing for the last decade. So their story honestly begins in 2010 when the guy I showed in the earlier slide, Charlie, he's one of their maintenance engineers, he said, hey, why is that chiller running in the winter? That's all it was. He just opened up with a question. What is this system doing and why is it doing it? So turns out he had control, and so he turned the chiller off in the winter. And so about a year and a half later, we were performing a detailed energy audit of the center, and he mentioned that he'd started doing the chiller shutoffs, and he had a couple years of data, and we pulled it, and we ran some nerdy analysis on it, and it turns out they were saving about $19,000 a year in combined energy and demand savings just from turning the chiller off and doing much more aggressive economizing at the air handlers. That's really interesting. Okay, so that's kind of where they got their feet wet. Over the course of the next decade, every item on this list was either something implemented from the energy audit that was a low cost or no cost operational opportunity, or it was a planned investment in a normal capital cycle, except for the lighting renovation, which was upgrading the lights because, you know, that's how efficiency works. The chillers, the boilers, the HVAC upgrades, the controls upgrades, everything was already part of a multi-year capital planning cycle. So this building didn't go for efficiency's sake. This building said, hey, let's start investing in efficiency because we're going to be investing in the building anyway. So let's look at what happened over the course of that decade. This is just a snapshot of data from 2008 to 2018. Without explaining too much, the blue lines are where the building would have been operating in normal weather years going forward, and the red lines were where they actually operated, both in electric and natural gas. The green interim areas between the two are savings. So they've reduced the energy by quite a bit, and while I would love to take credit for all or most of it, really their staff, which we'll talk about soon, deserves all the credit for pushing this forward and pushing this beast uphill. Over the course of that decade, right now, they're actually approaching about $1.5 million in cumulative savings, and they've reduced their energy consumption by about 50%. And this is all weather normalized, pulling weather, hot summers, cold winters out as a variable to look at. So here, speaking of the 50% solution series, which is the title of our track here, here's a building that actually did it, and they're down 50%, and that is an existing building, and they weren't gut rehabbing this thing. They were just upgrading plants and upgrading equipment that was approaching end of life, and they did it in a sensible way and in a method of thinking about incremental investment. So the industry, those nerds of us out there who talk about energy all the time, define a cut of about 50% as a deep energy retrofit. So the question usually comes up, how do we do it? Because usually deep energy retrofit is someone looks at a building and puts a whole bunch of money in, ripping the thing down to its bones and building it back up, and taking the building basically offline the entire time. And this building did not do that. I like to focus on 4 big areas of organic strategic energy management that really were the backbone of this building achieving what it achieved. The first was a kind of a really important cultural element. There's a saying that culture eats strategy for lunch. It doesn't matter how good your plan is if your people can't get in line. So they had a couple of curious and engaged champions who worked at the facility. They had a mindset already of continuous improvement, and they tend to not accept the word no as an answer to almost any question that's asked, which I find that to be particularly interesting. They really were just, we're going to break through the wall and we're going to do this type of folks. The second, again, as I've mentioned, this is all done over capital cycles, no massive renovation, incremental investment as opposed to efficiency for the sake of efficiency, and focusing on opportunity areas. They had a team, so they had internal architectural staff. They had us at Go as their energy consultants and commissioning agents. They had a design team with Corda, but they had a bunch of other partners who really got on board with the mission and the idea and the thread of energy efficiency of investment for the sake of the building was at the forefront of every meeting and the forefront of almost every decision that was made. and it was constantly at the table, and it was well represented, and I think that had a lot to do with it getting there. Two other really important goals I want to mention is that as a taxpayer in the state of Ohio, I think it's important that they kept continuously saying out loud that one of the goals of investing in the building was to do effective use of public funding to reduce their operating costs in a way that paid back and made sense in a cash flow basis, so that they could make the argument that they were using the public's funding wisely to, in the future, reduce the need for funding this building, instead of having energy just blow out the door and be waste. They also did not want to engage in any performance contracts, and there was no ESCO involved. Nothing against performance contracts at all. They're absolutely a method of improving a building, but there's a lot of data out there to suggest that performance contracts on order of bringing about 50% of the energy savings that are promised. So they really didn't want to go into a method of having to do a constant justification of ongoing measurement verification for performance contracting. So a second point they made was, and I kind of want to highlight here, is I keep harping on the idea that they were doing this during capital and planning cycles. So this is just an example during the chiller plant replacement. You know, they got to a point in half a decade ago or so where they realized, you know, they're housing a lot of historical archives that need museum quality temperature and humidity controls, and their current system was well beyond its 30 plus year life. Chiller failures and other related failures were starting to mount up, and they were planning ahead to go ahead and finally replace approximately a 500-ton chiller. So we worked with the representatives of the building and the design team to put our heads together to figure out a way to select the chiller a little bit more intelligently. And so what we did was we got a bunch of data that chiller manufacturers are not used to usually giving out when they're asked, but we told them they couldn't bid unless they gave us the information. So it turns out it magically showed up. And we ended up getting 8 chiller options for this facility. So they ended up going with option number 6. And I want to point out that the light blue on the bottom of the graph was the initial cost of the chiller, and the dark blue was the lifetime ownership and energy cost of the chiller. So slightly out of whack with each other, which one's more overall impactful over the 20 years. But they could have just gone with the most expensive chiller, which was about a $32,000 cost add. And on paper, this chiller had a higher rated efficiency, a higher IPLV, a higher, you know, more what it looked like bells and whistles. But because of the way the performance data for this chiller fell out, the way this building uses energy, the way this load profile happens in this building, it would actually cost them about $100,000 more over the life cycle to operate this quote unquote more efficient, more expensive chiller. So chiller number 6 was a little bit less expensive and had a lot more better life cycle cost. Again, they could have also gone with the cheapest chiller and saved 60 grand up front, but again, oddly enough, spend about $100,000 over the life cycle. So this is just an example of how picking the optimum piece of equipment, and I'm not saying for every 5 horsepower motor or pump, we need to be doing massive life cycle costing, but for significant pieces of equipment, the time of investment is the time to make that optimization decision. So this is just one of the many things they replaced or modified, but did so with the sake of, we're doing it anyway. Let's make sure we're making the right energy decision for this building, not just for the first cost, but also making sure that we understand that we have a justifiable life cycle cost to prove out to stakeholders interested in the building. So over the course of this decade, you know, we're starting to look at this building and understand it's making some progress. So a simple graph here is that back in 2009, their energy use intensity of, you know, kilobitu's per square foot went from about a 95 to about a 55 in about a decade. It's about a 50% reduction. And when we look at that reduction, and when we get to 55, it started getting us scratching our heads saying, well, wait, this is a 55. That's a pretty low energy building now. It's a pretty energy efficient building. Where do zero energy buildings land before they install renewable energy? And it turns out that the 80th percentile of all those buildings I showed back on the US map earlier, the 80th percentile is at 40 kW2 per square foot, which means when you start getting close to 40, you start getting into a range that is suggested that it's possible that you could be a zero energy building if you start either dropping a little bit further or start producing enough energy renewably on site. And it turns out they already had enough projects to get from a 55 to close to a 40. I grayed out the right side of the graph because it gets confusing every time I show it. But the point is they already had a bunch of products in the queue, and they've actually accomplished a few of them since then. This is an end of 2017 snapshot. I would like to get a 2020 snapshot. I haven't just gotten around to it yet. But the point is we're approaching zero energy ready with this facility. So as a temporary aside, it's also in that same time period, electricity prices sort of went up in blue quite a bit. And natural gas prices also went down in red also quite a bit. And it's really important to understand the difference, and when you're communicating to stakeholders in your organization about the difference between just dropping energy and dropping energy costs, because a drop in energy costs could come from efficiency efforts. It could also come from the actual costs going down. The converse is also true. So tangent over, back to the story. So it turns out that some preliminary analysis suggests that they pretty much need about half the parking lot of covered parking to get the generation they need to get to zero. The little table on the right shows 3 different definitions. Let's not worry about the exact definition. It all lands in about 1.5 to 2.5 megawatts of solar, depending on how you spin the numbers, which ends up being on the 2.5 megawatt range, about half the parking lot, which is actually quite interesting. That's all they would need at their current energy use to get to zero. It does bring up a very tricky and touchy subject of electrification, depending on which definition you pick. There cannot be on-site combustion if you go with the carbon definition. So if you do end up going the carbon route, there's a lot of considerations to put in of the cost of fuel, electric versus natural gas, the concept of massive shift of new and existing infrastructure. And we can make renewable natural gas by storing electricity by using 2 chemical reactions. However, it's a pretty inefficient version of battery storage. So that aside, the answer that we saw so far was it's plausible, it's physically capable. Now, is it economically capable? Can they get there? So the Ohio History Center, like a number of public entities, is looking at possibly engaging in a power purchase agreement to possibly be an economic silver bullet to see if we collectively can get towards this zero goal. So for those of you not understanding what a power purchase agreement is or haven't heard before, Vivi can help explain it to you. She's there on the right with her fluffy hair from yesterday. In a power purchase agreement, a third party comes to your site, basically. They own, finance, install, maintain, and do all the grid stuff with a renewable energy system. Traditionally, it's solar photovoltaic. Yes, there are other different technologies deployed, but usually it's solar photovoltaic. They help, this mechanism also helps become a bridge for non-taxable entities like school districts, some hospitals, the Ohio History Center, city governments, state governments, et cetera, to the federal tax credits that, while they are starting to decline, are still absolutely there for the next few years, and accelerated depreciation. And there's also been a major uptake in the last few years. I wish I'd pulled this slide, but there's a graphic the last 5 years of renewable energy deals that the Renewable Energy Buyers Association put together. And it's something like 70 to 90% of all renewable energy coming online is through some version of a power purchase agreement. There are lots of sub-definitions, but you don't need to worry about them today. They can be on and off your site, but PPAs are where the industry is really seeing a lot of its activity. So we decided, like, let's play out a 30-year cash flow scenario. This is without net present value. Actually, net present value would make the numbers look even better. But using some kind of typical Ohio numbers, the blue graphs here are the cash flow of the 3 different power purchase agreement options that we looked at versus the orange lines of actually the organization going out for a loan versus the organization in black miraculously having enough money just out of pocket to pay for a system. The only point of this was not to get the exact detailed analysis. It was to suggest and understand that it is very plausible that depending on the aggressiveness of a bid and how you get your PPA organized, you could see cash flow positive installation of solar energy on this site here in sunny old Ohio from day one. There's a lot of scenarios where it stays not too negative as well, but cash flow positive is actually very well within the bid cards. And we're actually advising a couple of clients right now through their own PPA RFPs out to the market to try to figure out if they can get good bid pricing on this stuff, because it seems like it's a very good time to be getting solar up on your site. And there's a lot of data to suggest that that's where a lot of the industry activity in the next couple of years is going to be. So what about you all? I'm sitting here in my basement in the midst of a global pandemic, thinking about probably the most important issue of our time, of climate change. However, in the light of COVID-19, it looks just slightly less important for the time being. But how do these two go together? Is there something about it where these are related, or is there a co-benefit to thought here? So, so 20, 30 district members, you're all sitting there in your homes, your basements. Sometimes, some of you might be in offices, and if you're able to be in your offices safely, that's great. Some of us are being driven a little bit nuts by the kids at home. But we kind of coincidentally, before the whole pandemic hit, we engaged a bunch of graduate students at the University of Dayton, undergraduate students at the University of Dayton, to do a bunch of grid level energy nerd analysis for us. We had a couple of reasons for it, but we'll reserve the right to be crazy. So we asked the kids to look at the entire PJM grid. PJM is the grid that we're all part of here in Ohio. It used to stand for Pennsylvania, Jersey, Maryland, but it's arguably most of the East Coast, Northeast Coast. PJM puts data out. And so this is a snapshot from March 17th of just the maximum power being used on the grid at a given time. And the dashed line is kind of a normal kind of profile for that day. And we make two observations from this graph, and I'll reserve the right to just make over-sweeping statements here. The first is that we're all sleeping in a little bit and not commuting. So the grid peak in the morning is shifting forward between 1 and 2 hours, which is just kind of fun. The second observation is the one that I'm particularly angry about, which is that the afternoon peak only seems to be about 5% lower than it had been on a typical March 17th. And we're seeing this profile kind of play itself out on other different days, which makes me want to go to Vegas by car, obviously not plane, because I can't get there by plane right now, and bet my entire 401k on the fact that buildings are not turning off, that we are occupying and energizing the buildings out there that we all used to work in at a level that is almost as if we're all still there, but many people are not at these buildings. There's a lot of buildings sitting there idle right now. And in the modern era, when you're watching news of thousands upon thousands, possibly hundreds of thousands upon hundreds of thousands in the state of people being furloughed and unemployed, my head jumps to the concept of lean manufacturing. In lean manufacturing, if you've ever heard of Six Sigma, that kind of big mumbo jumbo words, it turns out that every dollar, every effort you do not put into the final product that gets sold or to the client is waste, right? So if energy is being used to keep a building lit, cool, and ventilated to a certain level as if hundreds of thousands of people were in it, and there's 6 people, we're wasting a lot of money as a society. We're also laying people off. And if we could be putting money into the people instead of into the building, we might have a better recovery in this. So what about you? Let's bring this back to you. There's a couple mantras I want everyone to kind of chant here, things you want to think about with operational efficiency. The first question is, think about your building. Why is something on? What does that thing do? Do we need it? Is it at the right setting? And can we just not use it? This is exactly where our friends at the Cincinnati Zoo, if anyone from Cincinnati Zoo is on, hi, I don't see you, but they started their decade-long quest for going crazy big on energy efficiency and other such things by asking these basic questions. Just look, why is it plugged in? Why are we running it this way? This is stuff we could be sending our staff into buildings right now doing, turning buildings and scaling back, because we've got many more weeks of this than we all want to agree that we've got coming to us. And so turning buildings back might be able to save enough money to arguably keep people on and employed. If I were one of you who had a building or a campus of buildings or portfolio of buildings and I wanted to engage on this topic, first thing I would do is I would send some staff through for a walkthrough. And if I had a building automation system, I would start observing it. And the first thing I would look for is, what are my schedules? What are my settings? What can I turn off? What can I idle? And what pieces of equipment can I consolidate? And from hundreds of energy audits from our company that we've done and our collective experience of the energy nerds here at Go, one of the biggest opportunities we see, whether it's a pandemic or not, is that thermostat settings are either not aggressive enough, or during unoccupied times, like nights and weekends, we are not setting our buildings back. And this is usually to the tune of 5 to 15, maybe 5 to 20% total energy use in a building, a lot of commercial buildings. So this is one of the greatest and easiest areas of impact that we could be making right now, is setting our buildings back. Common barriers for this are, oh, we can't set this one air handler back because of X, Y, or Z reason, or Bill comes in at 5 a.m. and he doesn't want to be hot or cold. And that usually just puts a pin in the entire balloon. And we want to remind everyone that usually your building has more than one zone and more than one setting, and you don't have to achieve 100% of your savings potential. You can achieve 50% of your savings potential. So if I was out there looking in buildings right now, I would be asking, what are my HVAC settings? What are my fan settings? And can I optimize ventilation, right? I'm not suggesting shutting ventilation off to your buildings. That's how we get sick building syndrome and the 70s repeating itself again. However, we can be turning our ventilation back, and we can be reducing ventilation to spaces, minimizing lighting use, dimming lights when possible, and looking for opportunities in pumps and fans, like scaling back percent flow settings. Now that's the today. That's the if I were to run out into the building today and start looking for opportunity. Now, for those of you who made it through the 2008 recession time period, you also remember that sometimes programs come along that we usually call stimulus programs. And stimulus programs frequently are looking for shovel-ready projects. So while we're looking at our buildings today for immediate savings, near-term or medium-term savings opportunities can be identified. We can start looking for shovel-ready projects, such as almost every building still has some metal halides or some T12 or T8 fluorescent lights, both interior and exterior for some of these technologies. And a one-to-one lighting renovation to LED is a simple, easy project to kind of line up and think through and get budgeted and figure out some basic logistics for. Definitely there are more effective ways of lighting renovation, such as asking, am I providing the correct amount of light to a space? Can I reduce the number of fixtures? But getting a lighting renovation project lined up would be a pretty good shovel-ready project for people to be thinking if that's an opportunity in your building. Another one to be looking for is light to heavy controls upgrades. Asking yourself if your controls are able to be accessed remotely. Can your controls give you the ability to set back or schedule your equipment more aggressively? Can you change the supply temperature of air or water in your building systems? That can frequently have a supplier temperature reset, for example, based on outdoor air. There's lots of ways to look at how energy is being used from a water and energy flow perspective. Looking for opportunities for where your lights don't turn off when occupants there or when there's no dimming opportunity. Looking at opportunities for, can we optimize how this controller is controlling parts of my chiller and boiler plant? And are there other ways to aggressively approach sequence of operations in my buildings? So controls opportunities are usually not that bad or not that hard to start setting up from a shovel-ready perspective. Just like the Ohio History Center, back at that terrible table I showed a couple slides ago, start looking for HVAC units, air handlers, rooftop units, etc., chillers, boilers that might be approaching their end of life, where getting a shovel-ready approximate replacement product together might be very valuable for applying for a possible grant or stimulus funds. Looking for opportunities in your motors for higher efficiency, finding out if variable control on those motors with a VFD might be appropriate. And if you have a kitchen, holy cow, variable hood control and local controllers for your low flow, for lower flow when you don't need to be at the same ventilation flow, go talk to Malink or one of these other companies who has really good kitchen controls. And these are good shovel-ready products to be considering. So I just want to bring an actual case study in. In 2018, we did a study for a particularly large school district. It took about 6 months and better part of 15 people to do. However, of their $13.5 million that they spend annually, we found between 10 and 20% savings opportunity, depending on how conservative or aggressive you ran the numbers for them. Over half of those opportunities were low to no cost opportunities. They were having someone actually just look at the settings and go, no, we don't run that late into the night, or no, that temperature does not need to be at that zone. A lot of building owners already paid for the features in these buildings that should be able to control them efficiently. Usually the question is, are those features actually being used in a way that saves energy? Are those features being used to maintain things appropriately and turning off or setting back the systems when they're not needed, regardless of pandemics? So time to throw rocks. I can keep presenting. I also can't see any of the folks on. So if you want me to, I can just take questions. And if Chris, Tom, or Elizabeth, if you want to moderate, feel free. Otherwise, I'll sit here and smile at the screen for 15 minutes.
Yeah, Greg, we just had a question come in on the group chat asking if any of the solar installations at the Cincinnati Zoo are classified as PPA, if you're aware of that or not.
That's a great question. I can't believe I didn't bring it up. So the Cincinnati Zoo, about 8 years ago, engaged in one of our region's most interesting and largest PPAs. They work with Malink to set up their approximately 1.5 megawatts of solar in their parking lot, which I've parked underneath many times and been happy that rain and snow are not on my car, or in the summer that my car is cooler. Yeah, their original arrangement was a power purchase agreement. So even 8 years ago, this was when the beginnings of power purchase agreements were starting to hit the Midwest in any certain way, and this was the effective vehicle they used. In recent memory, they ended the PPA publicly to buy down the system from the link, and so now they are full owners of the system. But there's economic reasons that you, as a owner of a renewable energy system, may or may not decide to continue doing the agreement or end it with a payoff to make it your own system. Great question.
As a follow-up, Greg, do you know if there's any other PPAs in Cincinnati?
So when people typically talk about PPAs, again, if you think of the Cincinnati Zoo, that is one of the subtypes called an on-site PPA, and it's usually where the renewable energy is installed behind your meter. So basically, it looks like to the grid as if you've taken a load off of your system, just like turning a generator on. There are some other PPAs in the southern to central Ohio region that are off-site PPAs, where someone goes and puts a big old field of solar up somewhere. And there have been a lot of announcements recently of different entities going out and engaging in long-term contracts to bring new renewable energy online through a PPA. But those are either through virtual PPAs or physical PPAs, which are not on your site, but also underneath this basket of types of PPAs your organization can engage on.
Another follow-up to the PPA discussion is just in terms of the finances. What's a typical payback for the renewable energy, or can you describe the cash flows a little bit more?
Absolutely. So when we get into renewable energy or any more complicated efficiency conversation, the first thing I try to tell people is get the term simple payback out, because it's a pretty archaic term. Payback is not how most business people that I talk to think. They talk in cash flow. It doesn't matter what the payback is as long as cash flow is positive to neutral. So most power purchase agreements that we're seeing nowadays they used to be 30 years. Maybe the upper limit now is closer to 25 years. You can see them getting as short as 12 years, but maybe closer to 15 on the real short end. So these are not short-term deals. You're signing up for probably arguably 15 to 20 years for the system. But depending on all of those levers you pull, from starting price to energy escalation price to interest rate to internal discount rate, all those economic mumbo jumbo terms, there's a lot of evidence and organizations talking about how they're getting PPAs set up to be cash flow neutral to positive from the moment they set them up. And a lot of market data supports that decent enough size organizations installing usually well over a megawatt worth of solar should be able to accomplish the same result.
All right, so we had a couple come in. Looks like the first one was Cincinnati has a lot of old historic buildings. Thinking about the over the Rhine area, what are your suggestions for revitalizing or the rehab of these types of buildings?
Yeah, that's historic buildings are the scratchy itch of the industry, right? So with a historic building, there's a number of reasons we want to keep the historic building, right? It is wholly unsustainable generally to knock the building down and rebuild a building, A. B, historic buildings have an architectural character that are very important to our cities and society for a variety of reasons that I won't go into. So when approaching a historic building, usually you're not going to be making a lot of external or aesthetic or visual modifications, which gives you some limitations. However, the predominant amount of changes we're looking at in efficiency come in the lighting and HVAC and controls realms. You know, you're never going to pay back. You're never going to replace windows in a building with high efficiency windows and justify it on paper just for the energy's sake. There's got to be other reasons for doing it. It usually doesn't come in a very good payback, but you know, you see a lot of historic building renovations go on out there, and it's very touchy-feely with that building, and really it takes the historical experts really getting down on the table with the efficiency and architectural folks and the mechanical folks and talking through what are the ways we can actually change this building, right? Like some buildings might have a boiler the size of my basement to heat 2 tiny offices, right? The replacement of old and inefficient and space inefficient technology, but even going in with high efficiency variable units like DRF units or other distributed technologies is usually a great place to start. In the end, putting renewable energy on a historic building might be prohibited, and so your on-site zero energy potential may not exist. However, that's why we're looking for like broader solutions as a society, and off-site renewables are going to become probably part of a really big portfolio approach for historic buildings going forward. That's a attempt to answer that one. I'm not an expert in historic building renovations, and I really applaud people I meet who are, because they seem to do a really good job.
Cool. We have, it looks like a 2-part. I'll take the first part on this one. So for the lighting question, on top of retrofitting halogen fixtures to LEDs, for example, in a warehouse, how does the interaction with occupancy sensors either increase the energy cost savings, or just how does that interaction kind of affect each other, retrofits along with OC sensors?
That's a really good question, because I think that's a couple of years ago, I would have said, we're really close to that being a reality. In 2020, the last 3 to 5 years, I've seen a lot of good examples of, look, we're going to put a sensor into a room. If we can use that sensor to turn the lights on and off, we can send a signal to the BAS with a 0 to 10 volt signal that just says the room is or is not occupied. And the concept of more than one system benefiting from the same sensor is both efficient from an effort and material standpoint and cost standpoint, but also really helps efficiency of the building. So the example I'll bring up is we were commissioning an installation at an academic institution, which they installed occupancy sensors on the wall. And the initial idea was just it was going to turn the lights on or off after a certain amount of inactivity or activity. And the controls folks were talking about, well, at the same time, we're installing these upgrades to the facilities HVAC. And honestly, they were rehabbing an old steam radiator system. And all they were doing was putting thermostatic valves on the radiators to say, give me heat or don't give me heat. And it's a really good way to affect these old steam systems and radiant systems in buildings. At the same time, they decided to just virtually tie the occupancy sensor signal back to the BAS and employ a 3-stage setting for the thermostats. So when we're in the room, let's pretend that the heating setting was 70 or 68. When no one was in the room, but it was during normal occupied times, that temperature backed down about 3 or 4 degrees to, let's call it 67 or 65, depending on the setting. And then when it was truly unoccupied during non-occupied times, it set back another 3 to 4 degrees. Same converse could happen on the cooling side. And it's a really effective way to be using technology for more than one purpose. And anyone doing occupancy sensor installations should probably be playing around with can I feed my HVAC with the same signal, because it has a lot of really significant energy reduction potential.
Cool. Along with the lighting discussion, I'll go to this one first, then pop back to the building envelope question. Someone asked if there are ballast dependent, for HID and fluorescence, they utilize ballasts. LEDs do not require ballast. So are you aware of any LED fixtures which can be retrofit onto the old fixture without removing the ballast in an effort to reduce initial cost?
So there are a very wide array of lighting renovation technologies. And I will caveat this with, I am neither an electrical engineer nor a lighting contractor, and you need to talk to your qualified versions of these, because if you don't, fires could happen in your buildings. And there's a recent example, if you've been watching the news, the Columbus City Schools had a couple fires that were started through the improper installation of the wrong thing in the wrong thing. That's as far as I can really go on that topic without getting into probably a lot of trouble. So turns out when you're upgrading these lighting fixtures, especially when we're talking about linear fluorescence, there are pretty much 4 big bucket areas of how you renovate. The first and cheapest is plug and play. You take the old lamp out, you get a lamp that's qualified to be run with a ballast, and there are specific ways to describe that. You plug it in like it's any other lamp, and you walk out of the room and you keep going. The benefit there is that it's a little bit cheaper up front, and those the costs on those lamps have come down dramatically in the last few years. The bad side of that is you still have a ballast, and ballasts are a failure point. They're a maintenance headache. So you're kicking the can on costs down the road by doing this upfront point. A lot of clients that we're seeing, and Nationwide Children's Hospital up here in Columbus did this recently. They went through and they did a version where they have the electrician snip out the ballast. They either remove it and recycle it then, or they leave it in place. They abandon it in place and put a bunch of stickers there saying, do not put this back. And they put in direct drive fixtures that do not require a ballast and actually could have a significant failure if the ballast is still there. That's kind of the second cost tier that takes your ballast off as a failure point. It's a little bit more costly, but it's also a lot, I'd say the predominant of the lighting renovations we're witnessing in the Columbus through Dayton, Cincinnati region are very heavily dependent in this direct drive version. There's another version where you rip out the guts of the fixture, you leave most of the metal there, you just snap in a few new pieces. So it's almost like having a new fixture. It has the built-in little LED dots that are hidden up in there, but it has a lot less cost than the new fixture, but it doesn't give you any of the aesthetic upgrade a new fixture really gives you. And then the highest cost is a full rip and replace on fixture.
Cool. All right, and the last question that we have for now is if a building's interior space is already unfinished or exposed, i.e. no drywall or finishes, does that make sense to still consider building envelope upgrades in order to increase the energy or cost savings?
Yeah, that is the affecting a building envelope, especially when you are not willing to or cannot modify its visual aesthetic, can be very hard, right? If your wall is 6 inches of brick, that's all your wall is, and you can't change it, you're out of luck, unless you can throw some insulation on there and then maybe rebuild in a faux brick wall in the interior or exterior. Should not dismay a building from approaching efficiency in the HVAC or lighting realm, but envelope can frequently be a pretty big constraint. And again, this really throws back that historical building question. It can be really tough to deal with the historic look, especially when it comes to brick, masonry, and things like that.
Greg, could you talk a little bit more about, for our commercial buildings, what kind of savings they could see with just doing kind of this low grade? We're trying to just do the low cost items versus kind of the higher cost. What's the return on investment?
Well, I'll tell you that the low cost, no cost stuff usually has a very immediate return on investment. It's usually staff time and minor amounts of programming to get accomplished. And across hundreds of energy audits and other products we've worked on over the years, usually the savings range of the low cost, no cost stuff is in the 5 to 15% range overall for a building. It can be higher, it can be lower, absolutely, but I would expect in the 5 to 15% range from really aggressive modification of settings, schedules, and other such things in the operational area. And there's a lot of examples we have of, you know, you can get a lot of low cost, no cost stuff done inside a chiller plant. Temperature setbacks alone can be 5 to 15%. They can even be higher. Aggressive scheduling, finding out when fans are or are not supposed to be running. Even if you're in the pandemic mode and you can't figure out a way to do it, but you can kind of limit your fan or your pump to be maximum of 85 or 90% flow instead of 100% flow for the time being. One, you're probably not going to notice during the spring season, and two, still going to probably serve your building, and they can be pretty good energy users. So there's a lot of ways to creatively approach a temporary, like pandemic version of knocking costs out in the real time now to keep the organization afloat and to invest in jobs. But in the long term, having our buildings be more efficient.
Yeah, and just to add on to that a little bit too, it's kind of fun if you can kind of play with these packages of energy savings opportunities. So if you are looking at your chiller system and you kind of start with your low cost, no cost, just changing settings, which is relatively no cost, then you can start to play with, okay, well, instead of just thinking about this as an individual opportunity, we also were really thinking about adding a heat exchanger and utilizing free cooling to shut off the chiller. Maybe I can start with just the settings changes and then also build into this higher capital. Then you look at it as a full project change, and then it can drive the simple payback or cash flow of adding a heat exchanger or whatever kind of capital heavy portion of the project it would be.
Hey, Greg.
Yeah.
It's Ken over at Duke Energy. Could you say a little bit about commissioning? I think there's a lot of definitions out there, and rather than have me sum that up, I wonder if you could pass through what your definition and thoughts are on commissioning of the building, retro commissioning, all those sorts of things.
Even having done commissioning now both as an individual, as a company for well over a decade now, commissioning can still feel like a buzzword. Lead or not lead, retro or not retro, envelope or not envelope. There's all of these subcomponents to it. And so the three things I think I'll try to say to simplify the answer on commissioning is, in my opinion, and in my reading of the ASHRAE, LEED, and other industry definitions of commissioning, commissioning is intended to be you, the owner, are getting a third party, someone who has no vested interest in the design or construction of your facility, onto your staff temporarily, basically. That person or team or third party's job is to look at your building design and construction process through your eyes, through your economic lenses, and ask questions, be the curious engineer, be there to critique, be there to advise and add and optimize, be there for a resource, but also can be there for being bad cop. One of the biggest points we ask on when we're looking at commissioning is, what do you need to pay another engineer for? Do you need to have another engineer babysitting the project there every day, every week, or is that your GC's job? Do you have to have the commissioning agent double checking every design calculation done by the design team, or are they there to help optimize and nudge and organizationally move where things are going? And do you need to throw the full budget at it, or can you still throw some budget at it and still get a lot of benefit out of it? I think that people who promote commissioning can sometimes be a little bit markety and say the payback on commissioning is X, Y, or Z. And I think it's really hard to put that together. But every time I get to the end of a project and I look at the items that we affected on a commissioning project, whether they be the better writing of sequence of operations, selecting a more efficient system, avoiding a retrofit that was going to happen a year after the building opened anyway, all the way through making sure that Melvin and Larry and the boiler team in the boiler room really knows how the system is intended to run, design, and have all the cheat sheets they need to operate efficiently. That thread of efficiency is what commissioning should be for your project. deploying that is very tactical, and I think it really starts with walking through that process as an owner with your commissioning agent to write out very explicit owner's product requirements and understand where you're going to give that commissioning agent teeth to act on your behalf, and what kind of trust relationship you have. Do you need to be in every decision they're making? Do you not? There's a lot of nuance to it, but the commissioning agent should be there to be kind of the voice for efficiency, ongoing operational efficiency, maintainability, and good design and construction for you who have, you have your job responsibilities. Let the commissioning agent kind of help be your technical representative.
Yeah, I'm a huge proponent of commissioning. I mean, certainly for new construction, for renovation, things like that. I mean, we've seen all kinds of just unconscionable things. I point to a large hospital here in Cincinnati that did a major expansion a number of years ago, and when we got around kicking the tires on it, I mean, something as simple as where the freestat was installed, it was on the wrong side of the coils, meaning it was offering no protection to a several $100,000 piece of equipment, right? I mean, how did that not get caught in construction?
Right.
So,
and I think that's important, and that's really important to bring up. Oh, sorry, did I cut you off? Keep going.
No, I was just saying these things happen, and then there's this whole notion of retro commissioning, where I think all too often I've seen companies hire out those services, and the commissioning agent will bring it back to design, as if design was ever appropriate to begin with. So systems get over-engineered all the time, right? Nobody wants to get called back because it's too cold or it's too hot or it's not moving enough air. So I think if, as the 2030 district, if there's a recommendation for commissioning services for members, I think that probably needs to be a root cause of that discussion around, what exactly that entails and what the outcome should look like. And for me, it's not bringing it back to design that might stem from 10 or 15 years ago.
Yeah, and to be fair as well, I mean, I think that new construction, major renovation, there's lots of parties, right? Design engineers got to bring their A game, architects got to bring their A game, construction personnel got to bring their A game. A good commissioning agent is not a guarantee of things going perfectly or well. In fact, a good commissioning agent sometimes has to let the design professionals have their creative license and leeway to get things done the way that they're going to do for a variety of reasons. And so I view the commissioning process as bringing on just another voice who has dedicated time to observe, comment, and ask, so that they have dedicated time to an effort time to look at it, as opposed to everyone doing all the stuff that they're supposed to do in their normal job responsibilities and trying to make the product maybe their pet project. The other thing that I see is for teams that don't really know a lot about probably more optimized, energy efficient or sustainable design, the commissioning agent sometimes is helping kind of pull that design from like, well, if code is legally the worst building I can build, can we just scoot this a little bit this way? And sometimes we've been the commissioning agent on a job where the design team is doing a killer job. They're really crushing it. And what we find ourselves is we're in the creative space to help optimize even further. So the value changes depending on the quality of the team, the type of project, and even the owner's level of engagement. And it can be a very nebulous thing. And defining what commissioning is for a project, it can be a project by project definition. Cool, well, we've run a little long. I'm happy to stay and answer questions because I'm not going anywhere, people. But thank you for taking an hour out of your day to amuse me from my basement, allow me to talk about something that I particularly like. Reach out for anyone who wants to have a virtual coffee sometime. I'm here for any questions following the presentation if you think of it a couple weeks later. I genuinely appreciate everyone's attendance today.
Thank you so much, Chris, and thank you so much, Greg. We appreciate it.
Thank you, guys.
Stay safe. Stay safe, everybody, please.
Bye.
Hey, Greg, can you still hear me by chance?
Yeah, I'm still here. What's up? Who is this?
This is Ryan from the Cincinnati Tool Bank.
Cool.
Is it possible for you to share a copy of your PowerPoint presentation with us?
Send me an email. My email address, I'll pull up on this. It's just, since I pull it down, it's graffio, GRAFFIO. So graffio at GoSustainableEnergy.com. The longest URL we could have ever picked. We couldn't have picked an abbreviation. If for some reason it doesn't work, email Tom or Elizabeth and they can send it over to you. Happy to talk further if you're interested. I mean, honestly, these problems are bigger than any one organization, and we should be approaching them from a non-zero sum fashion.
And Ryan, we'll also post this recording on our Cincinnati 2030 District YouTube channel.
Okay, great.
So yeah, you can rewatch it at your leisure. But we'll also plan to post the slides